Dear students, I'm Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nisonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now today we have come to our last video session on the topic sigma notation and series. And we will be solving two challenging questions in this session. So without any further delay, let us start with the first question of this session. Show that sigma r is ranging from 1 to 16 and the expression is 3 plus 5r plus 2 raised to the power of r is equal to 131798. So let us start with our answer. And we have learnt about the properties of sigma notation. We will be requiring those properties in order to solve this question. And in case you have not seen that video, you have not watched that video of mine, I would definitely be asking you to first go and watch that video of mine and then come back to this session. And you will be getting the link to my video on properties of sigma notation in the description area, as well as you will be getting a card, in card form as well. I'll be giving. Okay. So let us start with this question. First property that I'll be using is I'll be separating the three terms. So this can be written as, first of all, let me write the question. R is equal to 1 to 16, 3 plus 5r plus 2 raised to the power of r. This can be written as r equal to 1 to 16, 3 plus r equal to 1 to 16, 5r plus again sigma r equal to 1 to 16, 2 raised to the power of r. Okay. Next again I will be using another property of sigma notation. This is the argument or the expression is a constant. So this will be equal to the constant times the final value of the variable. So it is 3 times 16. You will be getting all these properties in that video. Okay. Totally explained and verified. Coming to the next term. 5r. So this 5 is a constant. I can take that 5 outside the sigma notation. This is also another property. So this is r equal to 1 to 16. And we have a single r over here. And this is r equal to 1 to 16. 2 to the power of r. Okay. Now I'll be just plugging in different values of r for these two terms. Okay. And 3 times 16 is 48 plus 5, and within the parenthesis, when r equal to 1, it is 1 plus 2 plus 3 and so on. It continues up to the number 16 because the end value or the final value of r is equal to 16. Okay. So this is one of the series, and you see this is an arithmetic series. The first term is 1 and the common difference is also equal to 1. Coming to the third term. This is also another sequence that you will be seeing. When r is equal to 1, it is 2 to the power of 1. R equal to 2, 2 to the power of 2. R equal to 3, 2 to the power of 3. So this is also another series, but this one is a geometric series. Last term is 2 to the power of 16 because the final value of r is equal to 16. Okay. So in this case, the first term is 2 and the common ratio is 2. Therefore, now that we have got the two series, one is an arithmetic series and the other is a geometric series, we will be using the formulas of the first in terms of an arithmetic series and of a geometric series. Okay. So since there are 16 terms in this series, the arithmetic series, in both the series in fact, so for n it is 16, right? N over 2, so it is 16 over 2 and the first term is 1 and the last term is 16. Plus this one is a geometric series and the formula will be u1, that is 2, and common ratio r is equal to 2. So it is 2 to the power of n is equal to 16 minus 1 over 2 minus 1. Okay, and 2 minus 1 will be equal to 1 definitely, and this will be equal to 8. So we are having this as 48 plus 5 times 8 is 40. So it is 40 times 17 and this is plus 2 and 2 to the power of 16 minus 1. Let us see what is the value of this expression. It should be equal to this, but we have to verify. Okay. So it will be 48, the first term is 48 plus 40 times 17 plus 2 times 2 raised to the power of 16 minus 1. And what is the value? 131798. You see, it is 131798. So we write this as 131798. Therefore, we have shown that this expression is indeed equal to this number. Okay. So when you are having multiple terms, and now you can see the necessity of separating the terms. When I had shown you that this property in one of my previous video sessions, you may not have understood the importance of that property at that time. You may have thought that what is the need of this. Now you come to know that what is the need of having this property, because these are of different types. This is giving us an arithmetic sequence, this is giving us a geometric sequence. You may say that yes, of course, but we can just plug in the different values of r and we can just add these three terms every time for every value of r and then add them together. Definitely. But don't you think that that will be taking quite a lot of time? Because r is ranging from 1 to 16, and had r ranged between 1 and say 100 or 200, then in that case, do you think it feasible to just plug in every value of r and get the value of the expression for every value of r and add them together? No, it is not. It is definitely better to apply the formula. Okay. So for that, we have to separate the terms. Now let us come to the next question of this session. So the second question is, given that sigma k is equal to 1 to n and the expression is k, that means 1 plus 2 plus 3 plus 4 plus ... up to n. This is an arithmetic series. Obviously, the first one term is 1 and the common difference is also equal to 1. So, and there will be n number of terms. Therefore, the sum total of the first n terms will be n over 2 and the first term plus the last term. So, this is the thing that they have given. Instead of 1 plus n, they have written n plus 1. You don't have to show this. This is given. Okay. As well as this one is given. This is another series. It is 1 square plus 2 square plus 3 square. This way it is continuing up to n square. Okay. The expression is k square. K is running from 1 to n. And this is equal to this. N times n plus 1 times 2n plus 1 over 6. I am not going into the derivation of this part because that is not the question. The question is, write sigma k equal to 1 to n, k plus 1 times k plus 2 in simplest form. Okay. So, let us start with our answer. So, first thing that we will be doing is we will be expanding. So, k equal to 1 to n, k plus 1 times k plus 2 is equal to k is equal to 1 to n, k times k is k square, k times 2 is 2k and 1 times k is k. 2k plus 1k is 3k and 1 times 2 is 2. Okay. Next, I'll be using the property of sigma notation to separate the three terms. So, this is equal to k equal to 1 to n, k square plus, I am taking this 3 outside using another property of sigma notation, k equal to 1 to n, k, and then it will be k equal to 1 to n, 2. Okay. So, let me just leave this. So, this is this one. For this one, I'll be writing this identity as. So, it is n times n plus 1 times 2n plus 1 over 6, and then it is plus 3 times n plus 1. No, let me write the next line, will not fit. So, I am using the next line. Let me write over here. So, it is n times n plus 1, n plus 1 and 2n plus 1 over 6 plus 3 times this, you know, n over 2, 1 plus n or n plus 1. So, I write this as n plus 1 and plus it was 2 and the last value of k is n, so it is plus 2. Okay. And next, I want to make all the denominators to be equal to 6, so I multiply this by 6, this is 1, so 1 multiplied by 6. Okay. And this should get multiplied by 3 and this should also get multiplied by 3. Okay. So, this is equal to, the denominator is 6 and it is n plus 1, 2n plus 1, and that is 9 n plus 1 plus 12 n. Okay. So, let us take n common. this is the common denominator 6, and I am having from these two terms, it is 2n squared, then it is n times 1 is n, and 1 times 2n is 2n. 2n plus n is 3n. Plus 1 times 1 is 1. Then it is, I have taken the n outside, so this has moved out. So it is 9n. Okay. So it is 9n plus 9. And this n has gone out, so it is plus 12. And this is 2n squared plus 3n plus 9 is n is 12n. And this is 1 plus 9 is 10, 10 plus 12 is 22. Over 6. I can at least take out 2 as the common factor from all the three terms. So it becomes 2n. N squared is 6n plus 11 over 6. These two will be getting cancelled, and I'll be having n times n squared plus 6n plus 11 over 3. 11 is a prime number, so I cannot do any further factorization of this part, and this will be our answer. This is the simplest form. Okay. So you see, in simplest form they have asked us to give the expression, and this is the simplest form that I can do. N times n squared plus 6n plus 11 over 3. Okay. So students, as I had said at the starting of this session, this was our last video session on the topic series and the sigma notation. We have done the questions where we have learned how to express a series in terms of a sigma notation, and also how, when the series is expressed in sigma notation, how to get the individual terms of a series. And also we have solved questions on arithmetic series and sigma notation. We have solved questions from geometric series and sigma notation. We have solved questions on some other type of series and sigma notation. In this very session, the first question was containing two different series in one question. So we have taken up a variety of questions, and we have known how to solve these questions in detail. I think you are no longer afraid of this topic, sigma notation, because I have seen most of the students are very much afraid or scared of this topic, sigma notation. Whenever the series, they will be able to answer the question if the series is given in terms of the individual term. But as soon as it is given in a sigma notation form, they just start to panic. They don't know what to do. Okay. So I don't think this is not the condition after going through all the 4 sessions that we have had in sigma notation. And our next video will be on growth and decay related to the geometric sequence. So let us stop over here for today. We'll be meeting very soon in our next video session. So students, thank you for watching this video till the end. Thank you for staying with me till the end. Please give this video a like in case you have found it useful. Please subscribe to my YouTube channel. It will be motivating me to make more math videos which may be helping you in your math classes. And please do not forget to press the bell icon. You will be getting notified as soon as I publish a new video. So bye for now.